Okay, today we're going to be looking at simultaneous differential equations. This is part of the second year further maths course. Core pure content, it's compulsory. Also referred to as perhaps coupled differential equations. There's another name for them. Essentially, you've got two equations with three unknowns. I need to eliminate them to bring it down to one equation with two unknowns. So let's just have a look at the general theory then before we get any further. So here we have a two-dimensional system. And it's two-dimensional because you have x and y as your two variables, and then you have t as your independent variable as well. But in theory, you could have a z dot with a linear system over here, and then we have our functions of t. If f of t and g of t are both 0, the system is said to be homogeneous. If either one of them is a non-zero function, then it is a non-homogeneous system. Okay, with these questions in this exam, the coefficients of x, y for both of these equations will all be constant. So a and b and c and d, they are all numbers and they are all given to you in the equation. This is part of the pure course, so you won't have to extract these differential equations from given text. You just need to solve equations that are given to you. And don't forget that a dot above, that means the derivative with respect to t. So this is dx by dt, and this is dy by dt. So the general idea is we need to eliminate either x or y. Question will tend to lead you down one of those two routes to give you a second order differential equation in the other variable, which we then solve using our normal methods of the auxiliary equation method. So it doesn't matter which you solve from a mathematical point of view, but just make sure you're following the question. So let's get rid of x. Now, unlike with simultaneous equations, it's not just a case of taking one and dumping it into the other. You've got quite a bit of work to do first. So what we're going to do is we are first going to differentiate the top equation. That will give us x double dot is equal to ax dot plus by dot plus the derivative of f. Okay, so that's a plus there. Plus the derivative of f with respect to t. So I've just differentiated with respect to t. And the reason why I've done that is I can now use the second equation to plug in my y dot. So this now becomes x double dot equals ax dot plus by dot, but I'm going to write y dot as cx plus dy plus g of t. So that's now y dot because that's what the second equation says. And then I've got my plus f primed of t. Now I have a y, which I need to get rid of. And actually, very much unlike simultaneous equations, algebraic ones, we are going to take this definition and plug it back in again. So it's two substitutions you need to make to get rid of the variable. Okay, and this is quite common in these types of questions. So we're going to have x double dot is going to be equal to ax dot plus bcx plus bd times y, but I'm going to rearrange this to make y the subject. So it's going to be bd plus, times, it's going to be x dot minus ax minus f of t, all divided by b. Then I have plus b times g of t. And don't forget your f primed of t. I know it looks really messy, but that's just because this is a very general case. Okay, we don't know A, B, C, or D. We don't know F or G. But this is just then, you can boil it down with a little bit of manipulation into x double dot plus something, which I'm going to call A1 times x dot, plus something else, which I'm going to call A2 times x, equals some function of h. Some function of t, which I'll call h. And once you get to this, then it's just a case of using the auxiliary equation method to solve that from there. Once you get a definition for x, we can then run that back up through here to find the definition for y. So that's the idea of these equations. Let's have a look at seeing this in action. So here we have an example question. This is a homogeneous system. We've got dx by dt is equal to 0.01y, and we've got dy by dt is equal to 0.02y minus 0.01x. So if you relate that back to the previous general case, a is 0 because there's no x here, b is 0.01, c is minus 0.01 because it's a coefficient of x, and d is 0.02. f of t is 0, there's no function of t here, and g of t is 0, there's no function of t here. That's what makes this system homogeneous. Okay, so again, I'm just going to eliminate y, but again, the question will be specific as to what it wants you to do. So to do that, I'm going to differentiate this first equation with respect to t. So I'm going to get d2x by dt squared is equal to 0.01 times dy by dt. Okay, so I've differentiated the first equation with respect to t. I now plug in the other one. So that's just going to be that times 0.01. So that's going to be 0.0002y minus 0.0001x. Okay, that's just me timesing dy by dt by 0.01. That's exactly what I've got over here. So it leaves me with this equation. So we've got d2x by dt squared in terms of y and x. So now we can use this definition of y to get rid of this y here, and that will leave me with a second order differential equation in terms of x. Okay, so no t's. So this is going to tell me that x double dot, okay, so that's the second derivative, is equal to 0.0002 times y, but y is 100 x dot. Okay, if I times that equation by 100. And then I've still got my 0.0001x. And a bit of rearranging, I'll get x double dot minus 0.02 x dot plus 0.001x is equal to 0. And that is now ready for the auxiliary equation method. So the auxiliary equation, that will be lambda squared minus 0.02 lambda plus 0.001, and I want that to be equal to 0. And that will give me two numbers for lambda, which are my auxiliary variables, or sorry, auxiliary constants. So I'll jump into equation solver. Maybe on degree 2. 1 minus 0.02 and 0.0001. That gives me that lambda is either 100th or, that looks like it's the only solution. Yes, that makes sense. 0.01 squared is that, and if I add two of those together and times by minus 1, I get that. So yes, that is the only solution, so it's a repeated root. In this case. So once you've got your lambda values, you can just state the answer. So x is going to be some linear function a plus bx times e to the lambda times t. Okay. So that is the general solution for x in terms of t. Now to get y, we use this. So y is the derivative of x with respect to t times 100. So using y is equal to 100 x dot, that's going to be 100 multiplied by this derivative. Now this is a product, okay, so we've got a function of x times, oh sorry, this should be a t there. We've got a function of t times a function of t, so it's a product, so I need to differentiate one then the other. So this is going to be easiest to differentiate, so it's just b, so it's going to be b e to the 0.01t, and then I need to do plus that times the differential of that. And the differential of that just brings the 100th down. So I get plus 0.01a plus 0.01 bt, and that is all times e to the 0.01t. Okay, and I can definitely tie that up. So it's going to be 100b plus a. So 100b plus a e to the 0.01t, and then I've also got plus bt e to the 0.01t. And we can see it's kind of of the same form. Okay, we've got a linear function times e to the 0.01t, but the linear part of it doesn't contain its own arbitrary constants. The constants are actually in terms of the arbitrary constants found from x. And that's a general solution. Okay, so there's y as a function of t and x as a function of t. Plug in your initial conditions if there are any to find your a's and b's. Example 2, a non-homogeneous case. So it's non-homogeneous now because we've got a function of t on the right hand side. Okay, so they're not f and g are not both zeros, therefore it's non-homogeneous. And also we've got some particular case over here. So that's, we will find the values of our arbitrary constants to finish the question off. Okay, so dx by dt is equal to this thing, dy by dt is equal to this thing. Again, the question would guide you through which to get rid of first. Mathematically, it doesn't matter, so we will just do what we've done the last couple of times and get rid of y. So I'm going to get x double dot. Okay, it's a differential of the left-hand side up here. That is going to equal 4x dot minus y dot plus 50 times the cosine of t. So I've differentiated all of the terms with respect to t. So that gets the double derivative x dot, y dot, and sine differentiates to cos. Okay, so now I've got my y dot here, so I'm going to plug that through from there. So that's going to equal 4x dot minus y dot, which is 6x, minus 3y, minus 50 cos t, plus 50 cos t. Okay, so this bit in here is the negative y dot. So in this case, it so happens that the trig functions cancel. We get 4x dot minus 6x plus 3y, but I don't want y, so I'm going to replace it with this definition up here, and that is going to be 4x times 3, so will be 12x. 4x plus 50 sine t, and then minus my x dot. And if I tidy all that up, I will get x double dot. On the right hand side, I've got 4x dot minus 3x dot is just a plus x dot, so that's going to be minus x dot when I bring it across. I've got a minus 6x plus a 12x, so that's plus 6x on this side. So when I bring it across, it'll be minus 6x. And then I've also got the 30 times 50 sine t, which is going to stay on the right because it's the non-homogeneous part. Okay, so there's my second order differential equation for x, and that's a case of solving that. So auxiliary equation, lambda squared minus lambda minus 6 equals 0, pretend it's homogeneous. You get lambda minus 3, lambda plus 2. So that tells us that lambda equals minus 2 or positive 3. So therefore the complementary function, not the general solution, the complementary function is x is equal to something times e to the minus 2t plus something else times e to the 3t. Okay, now we need to find a particular integral. And the right hand side is a trigonometric function of t. So we're going to try a trigonometric function. So I'm going to try x is equal to alpha times sine of t plus beta times the cosine of t. And that's not part of the complementary function, so this should work. X dot is then alpha times the cosine minus beta times the sine. And x double dot, you could actually differentiate that, but I tend to just replace it with minus x for these trig ones. It just makes the algebra a little bit easier. So plugging that up here, I'm going to get minus x dot minus 7x, because the x double dot is minus x. So minus x dot minus 7x. So through the differential equation, I'm going to get beta times sine minus alpha times the cosine. Okay, so that is minus x dot, minus that. Minus 7x, that's minus 7 of those, that's minus 7 alpha minus 7 beta. And that needs to equal, oh, sorry, not alpha and beta, minus 7 alpha sine minus 7 beta cosine. And that is going to equal 150 sine. And that's a case of equating coefficients because we want that to be always true. So that tells us then that beta minus 7 alpha is 150. But also, the coefficient of cos is 0, so we get alpha plus 7 beta is equal to 0. And if you solve those two equations, which I'm not going to do in my head, it's a set of simultaneous equations with two unknowns. I've got to put the first one in. So x is alpha and y is beta. So that's 1 alpha plus 7 beta is 0. And then I've also got minus 7 alpha plus a beta is 150. And that gives me that alpha is minus 21 and beta is 3. Okay. So you can just double check that just to make sure. So minus 7 times minus 21 is positive 147, and then add the 3 is 150, so that's good. And 7 of those is 21. Add those together, you get 0. So yeah, that works. It's great. So therefore, a particular integral then, alpha is minus 21 and beta is 3. That's in there. And then the general solution can be stated as being x is equal to the complementary function, which is ae to the minus 2t plus be to the 3t, plus my particular integral, which is minus 21 times sine of t plus 3 times the cosine of t. And that's the general solution to the differential equation. Okay, so that's x. Now I need to find y. And if we go back up here, we can express y in terms of x. Y is going to be 4x plus 50 sine t minus x dot. So it's going to jump ahead a few pages. That's okay. So we had y was equal to 4x plus 50 sine of t minus x dot. And we also have just found out that x is ae to the minus 2t plus be to the 3t minus 21 times the sine of t plus 3 times the cosine of t. Let's double check that that is correct. Yeah, that's what we got down here. A to the minus 2t, b to the 3t, minus 21 sine t plus 3 cos t. So we're going to use this definition in here to find y. Okay, so y is going to equal 4x. I'm going to do each term separately, I think. So 4x, that's going to be 4a. And then I'll also get a minus x dot, but x dot for this term, just doing this term, is minus 2a. So I get plus 2a, and that's all times e to the minus 2t. And then the next term, I get 4x, that's 4b. And then I'm going to get minus x dot. X dot here is 3b. So I get minus one of those, so that's minus 3b e to the 3t. Then I'm going to get 4 from there, 4 sines. So that's minus 84 sine of t. I've got a plus 50 sine of t there, which obviously goes with it. And then the derivative here will give me a sine, so that's going to be minus 3. And then finally my cos term, the derivative is going to give me a cos from there. So sine differentiates to cos. So I'm going to get plus 21 cos t from there. And I run that through. And then also get plus 12. Okay. If you need to run through each part, so you put 8 terms in for there, 8 terms in for there, plus the 9th term in the middle, that's fine, but I've just kind of compiled them together into their functions of t, and then we can simplify it down. So we have 6a e to the minus 2t plus b e to the 3t. And then we've got 87 minus 50 is 37, so minus 37 sine of t, and then we've got 21 plus 12, which is 33, times the cosine t. And that's the general solution for y in terms of t, with the arbitrary function, arbitrary constants from our definition of x. Okay, so we've got x there and we've got y there. Okay, now that we've got our 2 general solutions, we can go back to the question to establish what those constants are. So we've got when t is 0, x is 0, and y is 15. So we're going to get when t is 0, x is 0. That tells us that a plus b plus 3 is 0. Okay, don't forget that when t is 0, sine will be 0, so that disappears. And exponential will go to 1, and cos goes to 1, so we get a plus b plus 3 is 0. And the other condition was when t is 0, y is 15. And that's going to give us 6a plus b. The 37 will go to 0, plus 33. And we want that to equal 15. Okay, so that's the value of y. And again, we've got a pair of simultaneous equations there, which we can look to solve. Which again, I'll use the calculator for, just because it's so easy to make a mistake, and you don't want to make silly mistakes from here. So a plus b is minus 3, and 6a plus b is 15 minus 33. So I get that a is minus 3, and b is 0. Okay, now we've got those definitions, we can therefore state x is minus 3 e to the minus 2t minus 21 times the sine of t plus 3 times the cosine of t, and y is 6 times a, which is minus 18 e to the minus 2t minus 37 times sine of t plus 33 times the cosine of t. And that is the solution to the system of differential equations. That will satisfy both the differential equations and satisfies the initial conditions. Okay, so therefore that is the particular solution. Okay, so that's one example of a non-homogeneous case. I have one further question. Okay. This is what I've called a contextual question. This might be more something you see in the exam. This is just a little bit more wordy, but you won't extract the differential equation from text. Okay, you'll always be given the system of equations to work from. It's just got a lot of wordy stuff around it, but everything I've just done is what you're going to be expected to do here. So let's read through this. A fish in a polluted lake absorbs a chemical into its bloodstream and body tissue. The amounts of chemical are modelled by this differential equation and this differential equation, which together is called a system of differential equations, where x is the amount in micrograms of chemical in the blood and y is the amount in micrograms of chemical in the body tissue. T is the time in days, and K is a constant which depends on the pollution level of the lake. Part I, a fish is placed into the lake where K is 5. Initially, x and y are both 0. Find x in terms of t and show that y is this thing. What's quite nice about this question is you're given y, so we can check our answer at the end of it. This will be the bulk of the marks of the question. This is where most of the work is going to come from. Those are parts 2 and 3, which we'll get to in a minute, but this is where the bulk of the marks is going to come from. I'm talking kind of 12 plus marks here for that part of the question. Okay, so I'm going to roll on to the next page. And we're going to put these differential equations down. So just going to copy them down so we can see them over here. So we've got x dot is equal to k minus 0.04x plus 0.01y, and y dot is equal to 0.03x minus 0.02y. Now, I know there's no t anywhere, but this is counted as a non-homogeneous system because there is this term here, which, yes, k is a constant, but it doesn't have an x or a y in it, so therefore it is non-homogeneous. And our function of t is just k, but it's not 0, so therefore it's non-homogeneous. Okay, so it says, just look at the wording of the question. Find x in terms of t and show that y is this thing. So that indicates that we're supposed to do x first, then roll that back through to find y, and then this should fall out. Okay, so we're going to find x first. So just like in my 2 other examples, we're going to eliminate y. So we're going to get x double dot. That's going to equal to the differential of k, which is 0 because k is a constant, at minus 0.04 x dot plus 0.01 y dot. And now we're going to use this definition here for y dot into the equation. Minus 0.04 x dot plus 0.01 y dot, which is 0.03x minus 0.02 y. Okay, can you that up a little bit? I'm going to get minus 0.04 x dot plus 0.0003x minus 0.0002y. And now we use the top equation to get rid of y. So that's going to be minus 0.04 x dot plus 0.0003x minus 0.0002y, but I'm going to write y as being 100x dot. Okay, so I'm timesing this equation by 100, and then bringing that across to this side, so that's going to be minus 100k plus 4x. Okay, and we can definitely tidy that up. So we're going to get x double dot. Coefficient of x dot, over here, we're going to have minus 0.04, and then I've also got minus 0.0002 times 100 is 0.02. That's going to give me minus 0.06, but I'm going to add it across the other side, so it's going to be plus 0.06 x dot. Then my coefficient of x, I've got 0.0003 minus 0.0002 times 4. So that's minus 0.0005. But again, I'm going to add that across the other side. So it's going to be plus 0.0005x for my coefficient of x. And then finally the constant, which is I've got negative times a negative, so it's just a positive. So that's going to equal 0.02 times k. Okay, and that's the right-hand side because that's not a coefficient of x or any of its derivatives. Okay, that is your function of t for the non-homogeneous case. Okay, so now we've got this, we can extract the auxiliary equation. So lambda squared plus 0.06 lambda plus 0.0005 is equal to 0. There's my auxiliary equation. Again, I'm going to run this through here. I don't want to make any silly mistakes in solving this, especially with all these decimals kicking around. And that gives me that lambda is minus 0.01, okay, minus 100th, or 0.05. Okay, so those are my two values of lambda. So then I can state my complementary function as being x is equal to some constant times e to the minus 0.01t plus some other constant times e to the minus 0.05t. Okay, particular integral. The right-hand side is a constant, therefore we're going to try x is equal to alpha. This implies that the two derivative terms will both be 0. Because when we differentiate a constant, they disappear. So we're left with 0.0005 alpha is equal to 0.02k. Make alpha the subject. We're going to do 0.02 divided by 0.0005, which is 40. So I get alpha is equal to 40k. Okay, so there's alpha. And it's in terms of k because my function was in terms of k. So I can't go any further than that. I don't know the value of k. Okay, so that's my particular integral. Therefore, my general solution is x is equal to ae to the minus 0.01t plus be to the minus 0.05t plus 40. Okay, so that's the general solution for x in terms of t. I now want to find y in terms of t. So again, I'm just going to go back up to this definition here, times it by 100 and rearrange to make y the subject. I'm going to get y is equal to 100x dot minus 100k plus 4x. Okay, so y is equal to 100x dot minus 100k plus 4x. That's using the original equation that was given to me. So I use this definition for x in here to give me y. So 100x dot. So the derivative of that, it times it by minus 0.01, times it by 100, it's just minus 1. So I get minus a e to the minus 0.01t. This one here, again, differentiate and times it by 100. So that's going to be minus 5b e to the minus 0.05t. When differentiate that, it disappears. Okay, so that's the 100x dot term. Minus 100k, and then plus 4x. So I'm going to get plus 4a e to the minus 0.01t plus 4b e to the minus 0.05t, and then plus 160k. Okay, and I could definitely simplify that. So I've got minus a plus 4a of those. That's 3a e to the minus 0.01t. Minus 5b plus 4b is just minus b e to the minus 0.05t. And got minus 100k plus 160k, so that's plus 60k. Okay, so there's my general solution for y, and there's my general solution for x. All right, just roll back to the question. Find x in terms of t and show that y is this. There's no arbitrary constants here, so this is a particular solution. So I need to use my initial conditions, and I'm told that initially x and y are both 0, and I'm also told that k is 5. Okay, so I've got k is 5, that's particular to this lake. X and y are both 0 when t is 0. Okay, initially t is 0. So I'll plug all those conditions in. So I get x equals 0. Apologies. X equals 0 when t equals 0. That's going to give me a plus b plus 200 equals 0. Okay. A plus b plus 200 equals 0. Okay, don't forget that k is now 5. Okay, just pop that over there as a reminder. And the other condition was when t equals 0, y equals 0. So if we look here, we're going to get 3a minus b plus 300. 3a minus b plus 300 equals 0. Okay, so that's again a pair of simultaneous equations. In fact, let's just add them together. We're going to get 4a plus 500 equals 0. So that tells me that a is minus 125. And that tells me that b is 75. Okay. Just double check that. That doesn't seem right. Let's be minus 75. Hey, this is why I should always use a calculator. Okay, just check the answers in. Simultaneous equations, 2 unknowns. Okay, a plus b is minus 200. 3a minus b is minus 300. A is minus 125, b is minus 75. Must have made a sign error. Right, okay. Cool. Right, so a is minus 125, b is minus 75. So that tells me then that x is equal to minus 125 e to the minus 0.01t minus 75 e to the minus 0.05t and then plus 40k, so that's plus 200. And y is equal to 3a, so that's minus 375 e to the minus 0.01t minus b, so that's plus 75 e to the minus 0.05t plus 60k, so that's plus 300. Oh, can't see any of that. There we go. So that's my x and y in terms of t, and let's just check that with the question. Make sure that makes sense. 300, that's a good sign. Minus 375 e to the minus 0.01t, minus 375 e to the minus 0.01t, and 75 e to the minus 0.05t, plus 75 e to the 0.05t. So that kind of confirms that that is all your working is correct. Because I showed that question, that answer was in the question, you might just want to just be careful with how you justify that. But to be honest, you've done all the working. You've got a and b written down here. You've got y in terms of a, b, and k. You've said that k is 5, so you'll probably be fine with that. Okay, so that's part I, and that's, as I said, where the bulk of the marks is going to come from. Okay, part 2. At some subsequent time, the now polluted fish is placed into a clean lake, that is, when k is 0. Time is now recorded from this point. Write down the general solution for x and y in terms of t. So this is going to be exactly the same system of differential equations, except now k is 0. So you'd expect the general solutions to be exactly the same, but k is 0. So my answer to part 2 is x is equal to, I'm going to call it a0, just to differentiate it from a, times e to the minus 0.01t plus b0 e to the minus 0.05t, and y, well, what was that? We got 3a, so that's 3a0 e to the minus 0.01t and minus b, so minus b0 e to the minus 0.05t. And I've just got the subscript zeros there just because these constants will be different to the initial model, because it's now a different model with a different k value, a different lake, so the arbitrary constants won't match up. Anyway, that's a system of general solutions to that differential equation. It's going to be exactly the same form, but with k as 0. I said nice easy. And then part 3, does the fish ever completely clear the pollution from both its bloodstream and body tissue? Explain your reasoning. So for part 3 now. For x to equal 0, this implies a0 e to the minus 0.01t plus b0 e to the minus 0.05t would equal 0. And similarly, 3a0 e to the minus 0.01t minus b0 e to the minus 0.05t is equal to 0. So we'd want both of these to be true. That's y is 0. Both of those would need to be true for the fish to have no chemical in its bloodstream and in its body tissue, because x was the chemical in the bloodstream, y was the chemical in the body tissue, so we want them both to be 0. So if we solve those simultaneously, we'll get that 4a0 equals 0, so that implies then that a0 is 0, that implies b0 is 0, which means the only possibility of this being true is if the fish had no chemical in it in the first place. However, this particular fish has just come out of a chemically polluted lake, so therefore it's always going to have pollution inside of it. Okay, so therefore no, since the fish has pollutant inside of it when t equals 0, x is identically 0 and y is 0, is the only solution to x and y are equal to 0. As in the functions x equals 0, y equals 0 is the only solution to when x and y are both 0. So yeah, that justifies it, but the answer is no. The fish will never be rid of its pollutant. Okay, hopefully you found that useful. That pretty much sums up all the ideas of coupled differential equations, or simultaneous differential equations if you like. It's just that extra step of taking the two equations in the first place and putting them into one equation to then use the auxiliary equation method, which you've been doing anyway. Okay. Thank you for watching. Hope you found it useful.